Today I'll talk about MATLAB. So after click MATLAB icon in the desktop, you will land this type of window. So here this is actually command window, this area white page, and this here you can put your comments and you will get the answer. This is workspace. Here all the variable what you put in that command window, so that will show. Here you can here that list of that available file you can see here, and this is the you can select the directory where you will load or save file here, so you can change your directory. And this is the all these toolbar, so you can use home button, plot, application, so many things you can do. Now I'll do operation one by one, and I'll tell you how things will actually work. Now this is your command window. So here you can do all this. You can do addition, subtraction, multiplication, right division, left division, exponential. Okay, so now here you can do that. Like if you want to add, suppose 5 plus 3, it is like a calculator. Okay, 5 plus 3, I can increase that font size. Okay, and 5 plus 3, then 5 minus 3, we can do the subtraction, then 5 multiplication 3, we'll get all these things. 5 divided by 3, we'll get all this. Then we'll also do some exponential, like 5 to the power 3, we can do that. Okay, so all these kind of things we can do. Now if you want to clear the screen, so we can put that CLC. If you put the CLC, that screen will be clear. Now here some special variable is there, so you can use the special variable like pi. Okay, so this is 3.1416. then EPS very small number, so you can see that 2.2041. then INF means infinity. Then you can nan means 0 by 0. Okay, so that is nan. Okay, so you will see that nan, and I is the complex number. Okay, and then real mean, real max, all these things you can do. Again I am doing CLC, clear skin, sorry, CLC, clear skin. Now many things you can do. Now here you can use the trigonometric function like sine. Suppose I can do one variable a is equal to pi. Okay, then we can calculate sine of pi. Okay, so that we can do. Then cos of pi, we can get cos trigonometric value. Then tan pi, we can do that. So many things. Now these are all are radian. Now if we want to do some, suppose that we want to calculate that degree values, like again I am doing CLC. Suppose a is equal to 45 degree. Okay, so for that we have to put sine d of 45. So we'll get that that here 45 is the degree value, sine will take, and we'll get that sine 45. Then cos d of that 45. So again that will take that degree value. So like this way we can do some trigonometric calculation. Then we can do exponential. So exponential is like a exp of 1, so it is like a e to the power 1. Okay, so like 2.7183. then log is nothing but natural log of something, maybe e. Okay, exp of 1. So what is the value of that? So we can this is the not natural, so that is 1. Okay, similarly we can do log 10 of something 10. What will be the value? So we'll get different value 1, right? So now if you want to do square root of something, so that is sqrt of suppose 5, right? So that way we can do that square root. Okay, so now we can do many things like complex. If suppose we have, again I'm doing CLC, suppose we have so we have complex numbers. Suppose z is equal to 5 plus 6i. Okay, so this is the complex number. Suppose if I want to calculate that absolute value abs of z, what will if I put like that, I'll get the absolute value. If I want to want that conjugate value, so we can put that conjugate of z, so we'll get conjugate value. If we want to get imaginary, so imag imaginary of z, we can get that. Okay, it is like that. So imaginary value, we can get real value, real of z, we can get all this real value. Okay, then we can also calculate angle, angle of that z, we can get that. Okay, so that is 8.761. Similarly, we can do factorial, we can GCD, prime numbers, everything. So now we can also do matrix, determinant, trace, rank, inverse, experimental things, square root of matrix. We can we can do that. So we'll later we'll explore this matrix. Okay, now here whatever we'll get that answer, that is that predefined variable. So pi, EPS already I talk about. Many keywords that keywords are there, like break, case, catch, class depth, continue, else, if, for, many things are there, many keywords are there. Okay, now here if you want to get that directory, suppose you want to know the working directory, so it is like that, MATLAB drive example, it is like that. So here many keywords are there, cd, directory, is, path. So then you also general information, suppose computer type, clock, date, more. So if you just type it here, you will get that. And control C, suppose if you want to kill the any current command execution, so you can put control C. And if you want to quit the MATLAB, you can just put quit command, it will be quit. Now same as if you put exit, that MATLAB will exit. So many things are there. Suppose if you want to help of some command, so you can put help, we, all these things are here. So even if you see CLC I am putting, so that is clear command window, command history is lost. Okay, so home as the same as CLC. CLF, clear the figure window. Suppose if you draw the figure window and if you want to close, so you have to put CLF. Similarly here again, if I do all this again, we can do. So I put CLC, and then suppose a is equal to 5, this is variable, and b is equal to something 3. Okay, so we can do the calculation. C is equal to a plus b, something like that. Then d is equal to a minus b, we can do that. So many things. Even we can calculate g is equal to sqrt of a. Okay, a, so we can do many things, sqrt of a. So we can calculate many things, and we can calculate, suppose j is equal to cos of a, so we can do that. So whatever comments here, we can do that addition, subtraction, multiplication, division, square root, exponential, sine, cos, natural logarithm. So natural logarithm is log a. Even we can do that combination of addition of multiplication and exponential. So we can do that. It is like a calculator, like that I is equal to a plus b into bracket. We can put the bracket, and then we can do the multiplied c. Sorry, c is not here, so a, okay, c is there, c to the power 8. We can do all this calculation. Okay, then these are the exercise we can do. Okay, so this is like 3 to the power 4, you will get that. Even so many things. So I'm doing that 6 is 2 to the power 8. Okay, divided by, it is like a calculator, nothing but 1 minus 2 to the power 5. Okay, so you'll get the answer. So, and we have to follow the BODMAS rule. BODMAS, BODMAS means first is BODMAS rule. So then bracket, addition, division, multiplication, so and then again addition, subtraction. So this type of things we can do. then we can 9. Suppose you know that area is r is equal to something, okay, pi by 3 minus 1, we can get that value, and then area is equal to that pi into r, we can write like that, we'll get the area. Then we can also calculate exponential and logarithm, like we can do some value log x is suppose 5, x is equal to 5, then we can calculate, okay, we can calculate log x. We can do anything. We can also calculate sine pi by 6, sine of pi by 6, we can do that type of calculation we can do. So please do that this exercise, we will learn more and more. Okay, then we can also create array, CLC. So clear screen, we can create array, like here array is like 1 to 3, so array is like it is like something 1, 2, 3, so we'll get the array. Okay, so another that we can also do the column, this is the row vector, okay, and column vector array. So column array, we can put the name, that column array is like you have to put 1, then semicolon, then 2 semicolon, then 3, so it will give the column array. Even you can create the range of the vector, suppose a range array, so that is equal to something like you have to put, suppose I want to calculate 0, this is the starting point, and then step size maybe suppose 1, then this is default 1, and then maybe 10 put, and this is end. Okay, so if we do that, we'll get this type of array. Okay, so now accessing single element we can also do. Suppose a range of array, suppose if I want to take this, so 1 2 3 4 5 6 7 8, a range of array of 8 will give that the 8th number element. Okay, so we'll get that 7. It is like that. Even we can also here if I put like a range of array, okay, so then starting point is like 0, and then ending point maybe the 7, so it'll get something. So integers must be positive integer or local, so this 0 is not correct, so it you have to do like that. So you will get the 0 1 2 3 4 5 6, means it is like 1 to 7, you'll get that. Okay, so now we can get the sum of this array. Okay, so like if you put sum of this range array, okay, so range array, you will get that sum of the all these element you will get. Similarly mean of that array, you'll get that. Suppose if you want to put mean of array, you will get something like this. Okay, so you can also get that maximum of this max, you will get that maximum value max, so it will be like 10. Okay, so here you can see this is the max, minimum is 0, so we can get that minimum. Okay, so that way we can do minimum. Okay, so we can do that. Now here is the one problem, so with this problem also we can do. Okay, so now here I am going to do that problem. So t is equal to 10 elements, so t is equal to, we can do 0, then step size 1, then 10, so you'll get that. And then we can get x is equal to t, then star and sin t. So when we do that, so it follow matrix multiplication rule, but here it is a row vector, so that matrix multiplication rule is not valid here, so we have to put that dot will be the element multiplication. Okay, so you will get that. And then y, will get y is equal to, again it is also that element to element multiplication. Okay, so remember that if you don't do that dot, then it will give the error. Okay, So that way we can do all this calculation, t plus 1. Okay, so here if I do that, we'll get error. Okay, so the dimension error. Now if I put the dot, we'll get the result. Okay, so here we have to put again, see here, that is we need the dot. Again here also we need dot, so here we have to put dot. If we do that, we'll get the result. It is like that, remember that. So when you have to, when you are doing when you are creating that row vector, and if you multiply, so you have to put dot. So now next is creating matrix. So again CLC, then creating matrix we can do like here we can get, we already know that column vector. Now here we are generating matrix. So matrix, suppose M or X, we can put X is equal to small x. We can say x is equal to, like, first that row element 1 2 3, then comma, then 4 5 6, semicolon is actually separating the row, and then 7 8 9. If you do like that, you will get that matrix. Okay, now here again, so you can here that if you write, like, if you want to get the element like 6 means here 1, the first row and third column, sorry, second row third column. So A, if you write like that, sorry, A not A, x like 2 comma 3, so if you get that element, okay, so element 6, this element. Okay, now you can other way also, you can take that element x. Okay, so you have to count that 1 2 3 4 5 6 7 8. So x8, if you put that number also 6, it is like it is counting 1 2 3 4 5 6 7 8. Now if you put x8, so you'll get that. Now here you can also do that sub matrix, like A is actually sub matrix. So here x, you have to mention row. Suppose 1 is to 2 means 1 to 2 row, then you have to put comma, then you can mention the column may be 1 to 2 columns. So you will get the sub matrix, like here 1 2 4 5. It is like that, you can do that, you can get that. So you have to do, like, even if you suppose if you want row matrix only, row 3, this one, if you want this, suppose if you want this, you have to write b is equal to x, suppose 2, there's row, then you have to write column 1 is to 3. If you do like that, you will get that 4 5 6. Like that you can create extracting sub matrix. Now here, like addition subtraction, you can also do some similar way. Like here I'm creating two matrix. So A is equal to the 2 by 2 matrix. A is equal to 1 3, then semicolon 4 2. Another is, so enter, and then B matrix, that is similar way. So 2 3, then semicolon 5 7. Okay, then enter, we'll get the B matrix. Now we can do addition. So A plus B, if we do that, we'll get addition. A minus B, we'll get subtraction. We can also do multiplication. Obviously matrix multiplication rule should follow. Okay, so we'll get that multiplication. Now here if you put dot, so that is actually element to element multiplication, remember here. So here, see, this is follow the matrix multiplication rule, this is element to element. Element to element means if you here, so 1 into and 4 5, so 1 to 2, 4 into 5 4 5 20, 3 3 9, 2 7 14. So it is like a element to element multiplication, you remember. You can do the division also, A divided by B, so you will get all these things. So you can do that. Even if you do exponential, you can do A to the power 2. You can do that square, you can do anything. Okay, so that way you can create the matrix. Now here, so the address, already I talk about that. So address of that vector, already I told, like suppose again CLC. So again, so V is your row vector, like here. So 35 30 46, then 78, 23, 5, 14, 81, then 3, then 5. If you do like that, you will get that. And then here this is the position 1, 2, 3, 4, 5, 6, 7, 8, 9. Now if you write, if you put comment B, that MATLAB is a very case sensitive, remember that, B8. So if you put like that, you will get 83. So here 1, 2, 3, 4, 5, 6, 7, 8. Now if you put V9, you will get something 55. It is like that, very easy. Now you can also do addressing or addressing matrix also, and also you can create that sum matrix, right? So here is the example. You can do that. Many other things also we can create zero matrix like x, okay, zeros, okay, x is equal to, like here x is equal to zeros, okay, 3 2, so 3 comma 2. If you do like that, you'll get like this. So 3 row 2 column 0 0 matrix. Even you can also like y is equal to 1 ones of 2. If you put like that, you'll get that 2 by 2 matrix, that 1 1. Okay, now even if you get identity matrix, so for the suppose z is actually identity matrix, you can put e y e I of that 3. If you put that, you will get the identity matrix, 3 by 3 identity matrix. Now you suppose if I put one A matrix like 5 6 7, then 8 5 9, then 8 5 2. So now I am creating one A matrix. Now I want to get the diagonal element, so di diagonal dig ag of A. If you put like that, you will get, if you put like A this, so you will get the diagonal element, so 5 5 2. If you want to calculate the size of A, so that also you can get size of A, so it will be 3 by 3 matrix. Okay, size of a 3 by 3 matrix. You can also get length, gth length of A, so you will get that. So 3 length. Okay, so you can also calculate determinant of A, so you can also get determinant. You can also get inverse inv of A. Okay, so this is inverse. Okay, you also calculate rank of A, so you can calculate rank. Okay, then find, suppose so here that A matrix is that, so 9, suppose find 9. So if I put that, if I define 9, okay, so if I put like that, so that will give how many numbers are there. So search for given value in the array, so one number is 9. It is like that. So you can use this all this that comments, inbuilt comments, right? So now you can do this matrix multiplication easy. Also you can do that kind of things, same thing coming again and again. Okay, I'm not doing all these things. Now you can use linspace. So linspace means linear spacing. So for that, suppose if you want to calculate linear spacing, like suppose v is equal to, suppose maybe starting point, so you have to put linspace. Okay, and then if you want to create suppose 10, this is the starting point, suppose 100, 10 to 100, sorry 0 to 100, I want 10 element. Okay, so you will get this, it will be comma, so this is comma, this is also comma, so you can get, so 10 element, right? If you put 11 element, so it will be like that. Okay, so if you want to create 6 element, so linear, so if you see here to here 20 40 60 80 100, so 6 element, so this that division will be equal. Okay, so that you can use linspace. So many more things are there. Okay, now row vector, column vector, all these things we did. Okay, so our array operation also we did. So linspace, so trigonometric function, using trigonometric function we can use we can use that linspace also, like here. So suppose theta is equal to, suppose that linspace theta value is 0 to 2 pi, 0 to 2 into pi, and then we need, suppose we want 100 points. Okay, now here if you put here the semicolon last, it is not visible. You can see that if you don't put, it will be visible. Okay, so now you can also calculate sine of theta. If you put that, you will get the result. Okay, it is like that. Even if you put cos of theta, you will get that. Okay, theta, so you'll get the result, right? So that you can easily do. Even you can also compute this question, like here, compute y coordinate of the line with a slope here. So now first you have to calculate x is equal to something 0, 1.5, then 3, 4, 5, 7, 9, 10. Okay, now m is given, m is equal to 0.5, then c is given, c is equal to -2, and then we have to get y coordinate. Y is equal to m into x plus c. If you do that, you will get all this y coordinate value. Okay, so that is there. Okay, now here you can, we already did that, so here is the syntax you can do. Okay, so if you copy and if you paste here, so you will get all this. Okay, so here you can, it is not visible because of this. Okay, now you can do point, circle, many things you can do here. Okay, so now you can easily do that. That geometric scale series you can do, so that you can do here. Okay, and you can put that. Okay, so now that here you can put, if you see here, limit is 2, so you can do that. You can create vector also. Okay, so this exercise is there, so vector you can create here. So suppose I am putting CLC, then vector is here, so this is the vector. Okay, so 0 to 0.2, 12, so here you will get that 60 element. So then you can also do this. Okay, so now this is the matrix, and you can also get size. Okay, so you can get that size of V's you can get, like here. So here you can see 1 into 61, so you can see that 1 to 61. Okay, so 61 row, 61 element, you can do that. So many things you can do. So here extract the first 10 element of each row of the matrix, displays that as a column vector. So that you also do. First you have to, you can extract all this. So if you put that, you will get something. So first you have to create m, right here, m you are already creating. So first 10 element you can get from this here. You have to put this command. Okay, now in matrix input already we know all these things we did. Okay, now that unit circle. So here now I'm going to do that plotting. So CLC, suppose plotting. So theta, first theta is like a 0 to 2 pi. So here 0 to 2 pi and 100 points. So if I don't put that semicolon, then it will show the value, as I don't want to show, so I am putting the semicolon. Then here x is equal to cos theta, y is equal to sin theta. If I put that, we'll get the result. Then if I plot x comma y, we'll get the plot. You can see that this is the plotting circle, so you'll get that plot. Okay, so now if we want to that axis equal, so we can put that axis equal you will get that perfect circle. Okay, so you went to level, so x level x-axis, y level y-axis, we can do that. You can see that. Okay, so there is a something problem here. You have to put that semicolon, so x-axis y-axis, so y level x level. Here you can put the x level, inverted single inverted comma. Okay, so you will get that x-axis y-axis. So many things. Title you can also give, so title again, that is giving that red, so single inverted comma. If you put like that, you will get that unit title circle. Then you can also get the copy. So many things you can do. Okay, so these are the exercise, you can go through it, you will learn more. Okay, so I mean line style. Okay, so if you want to put something like this, this one, plot, here plot, if you put something like this, if you put, so you'll see that, so you will get this type of plot. Okay, again if you do that x is equal, everything if you put, you will get the perfect circle. Okay, so here if you put x is equal, so here x is equal, so you will get that perfect circle. So you can do many ways. Okay, now you can also do sign plot, everything you can do. Okay, so many more examples are there. So here you can do linspace, and then you can create the different name. So if you want to help, you can take help plot, more plot, help plot, you can put this command. Okay, then you can also plot log scale, say log something, or semilog y, you can do that. Okay, like here, suppose again I'm closing this and I'm also putting CLC. Okay, so now if suppose I have this one. Okay, so then I have y is equal to this. We can also do some subplot, so many things we can do. So suppose subplot, so if I put all this command together, so this one you will get error. Now first semilog. Okay, so you'll get that semilog. So first you will get in the subplot, you'll get that semilog. You can enter, so you will get that semilog. It is like a semilog. Now if you want to put something here semilog, you will also get semilog. Or if you want to log, you can put this command. Okay, so if this will be see. So one is semilog plot, then log plot, you will get that. Okay, so many things you can do, many. So even you can plot overlay plots, you can do. You can. Now next I'll talk about function. There is a inline function that we can also do that. So I think next video I'll talk about how to write function. That's it for today's. Thank you.